All right, good morning, good afternoon, or good evening, everyone. Today we're going to be talking about dot plots. So once again, we should understand what that means. Dot plots are a way to display data graphically by using a small dot for each piece of each data piece. The data points are ordered from least to greatest. So here we have two examples of dot plots. Again, the name dot plot indicated because of the fact that we're using dots. You do see sometimes that they'll use maybe an X or like a check mark to represent those points, but they're still basically forming the same idea as a dot plot. So what we can see here, we see that we have this first dot plot for exercise in hours. And so this is based on data collected in the number of hours people exercised per week. So the first dot that we're seeing, so I'll go through with the highlighter here. So the first dot that we're seeing here is talking about 0 hours per week. We then see these 3 dots above the 1 hour per week. And so what that's saying is that there were 3 times that somebody said or somebody reported that they worked out or exercised for 1 hour per week. You will then see 3 dots for 2 hours per week, 2 dots for 3 hours per week. Nobody worked out for 4 hours a week. And then we have 1 person for 5, nobody for 6. 2 people claim that they exercised for 7 hours, and then 2 people for 12 hours. One of the things that you'll notice here is that we have our x-axis scale set up where we have all of those numbers, even if there isn't a dot above it. And that's important because that's going to help us to see our data shape, and we're going to talk about that in a moment. So you'll see that there's no one listed for 4, 6, 8, 9, 10, 11, and then 13 and 14 hours, but we still have those points on our x-axis in order to have an equal scale along the x-axis. We then also have data on video games here. So this is again talking about number of hours per week. So there was 1 person who said that they exercised for 0 hours per week, 2 people who said they, played video games for 0 hours per week, 2 people who said they played video games for 6 hours, 1 person who said they played for 7 hours, and so forth. So we can read this by looking at the frequency. So the dot plots are really a great way of seeing 2 things. 1, the frequency of how often something occurred, right? So we can see the more dots, the higher the spike, the more frequent that would be to occur. We can also see the shape of our data. So let's talk about that. So data shape comes in 3 different forms. So we can have data that is symmetric. And so we see in this first graph that we have kind of an equal spread on both the left and the right here. So we have this symmetric shape or symmetry about that center. We can also have data that's called skewed right. And so when we talk about skew, we're talking about which way the data is getting pulled in one way or the other based on some maybe unusual values. So we're skewed right in this one because we have the data values with that tail going off to the right. We can also say that something could be skewed left if we again have that tail taking us off to the left. So one of the things that can be really tricky with skew is that we describe the skew, whether it's to the right or to the left, based on that unusual data value, not necessarily based on the majority of our data. So what I mean by that is in this data set that is skewed to the right, I'm really seeing the majority of my data on the left, but it's getting pulled to the right. So we describe it based on which way that tail is getting pulled. So we would say that this is skewed right because we have that tail to the right-hand side. All right, so let's actually look back at our video game, right? So if we look, the majority of our data is happening here, but then we have that 1 data point of 0 hours playing video games. So how would we describe the skew of that data? We would look at which way that tail is pulling it. It's pulling it to the left, so we would actually say that that data is skewed left. Now, when we talk about the rest of our data set, we can also talk about our measures of center, and this is what we did on our last lesson. So the measures of center in these cases will be using our median or the mean, and it will really depend on if our data is skewed or not. When the data is skewed, meaning we're getting pulled either to the right or to the left, then the median is our best option. And we talked about that in the last lesson, because when we have those really high or really low values, that will skew our average. So we don't want to use that because it's going to get pulled one way or the other depending on the skew. So if our data is skewed, the median is actually a better measure of center, because it will be talking about the majority of our data. When our data is symmetric, though, we would use the mean as our best measure, right? And we talked about in the last lesson how when we talk about house values, that we would use median because that data value is usually skewed to the right, meaning that there would be some really high-end expensive houses. So the median would be a better measure of center if we have that skew. Now, what we're going to look at today is really creating, comparing, and reading our dot plots. So the first thing we're going to do here is create and discuss some dot plots. So below are the average flight times for two different companies. So we have Airjet Express and our data, and then Cross Country Airlines and their data. And so we're talking about flight time, so how long the flight would be for each different company. So we're going to construct a dot plot for each airline. So first I'm going to do Airjet Express. So we have our x-axis already set up for us. That's very nice of them. What we're going to do is we're going to put dots over those data points. And as I go through it, I like to cross off the numbers that I've used already so I can keep track of it. So I'm going to plot 2 points at 2 because there are two-hour flights. I'm going to plot 1, 2, 3 points at 3 because there are 3 3-hour flights. We're going to plot 2 points at 4, 1 point at 5, 1 point at 7, and then 2 points at 8. Now, one of the things that I try to do when I'm graphing these dot plots is I try to make sure that I am spacing things out equally. And that's really important vertically. So what I mean by that is when I'm looking at both the data set for 2 hours, 4 hours, and 8 hours, I want those to be about the same height because they're both going to have a frequency of 2. So I want to try and space it out so that they're going to be about the same height. All right, next we're going to do Cross Country Airlines. So I'm going to change my color here for this one. And so I look at my data set. This has 2 3-hour flights, 2 4-hour flights. So again, you're noticing that I'm trying to keep those about the same height. We then have 3 5-hour flights. So I can really see here, because of the way I'm spacing things out, that that's going to have a higher frequency. There are 2 6-hour flights and then 2 7-hour flights. So again, creating the dot plot is just taking those data values and plotting the points along the x-axis accordingly, right? We use dots or sometimes x's or checks. Okay, so we've created our dot plots. Now we want to describe the shape of each dot plot. So looking at Airjet Express, so this is our red one. So we would say, I'm going to use Airjet Express, I'm going to abbreviate here, is skewed to the right because we have the majority of our data here and then we're pulled off a tail to the right. I can also talk about Cross Country Airlines, and this one is really nice, and this one is definitely symmetric. And I can really see that if I were to like put a curve here, that I would get a nice symmetric even curve about that 5 hours. Next, we're actually going to calculate the mean and median for these flights. So here's where we have to remember, how did we calculate those things from the last lesson? And in the last lesson, we did it using the data set. So I would have used the data from back up top here, and I would have, for the mean, added all of those up and then divided by the number of numbers. So here I'm going to be adding up the 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus 7 plus 8 plus 8. And so we're going to get a sum of 49. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. So our mean is going to be 49 divided by 11. So we have a mean of about 4.45 repeating. All right, so the mean flight time for each company. So I'll switch back to my colors. So here for Airjet Express has a mean of 4.45 repeating. Now, since that is a nice repeating decimal, I'm going to use that repeating bar instead of rounding that number, right? If I don't need to round, I won't round. Okay, next we're going to do the average for cross-country airlines. So I'm going to add up 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 7. And so here we get a sum of 55, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as well. So our mean here would be 55 divided by 11, which gives us 5. So then for cross country, the mean is 5. Right, so we see that the mean is a tiny bit higher for cross-country airlines and a little bit lower for Airjet Express. Next, we want to find the median. Now, the median means the middle, and we found this looking at our data set written out by going into the middle when we were in numerical order. So we have it set up from least to greatest here. So what I can do is I can go back up to my data set, and I will cancel out left and right until I get into the middle. And I'm going to get, for Airjet Express, the median will be 4. And then I'm going to cancel out for cross-country airlines, crossing out left and right, working my way into the middle. For cross-country airlines, the median is 5. All right, so now I can see with my data set for both Airjet Express, I have both the mean and the median is a little bit lower, and they're not the same. But when I look at the mean and the median for cross-country airlines where that data is symmetric, the mean and the median are actually the same. And so that's why the mean would be a better indicator for cross-country airlines. So if they wanted to talk about their average flight time, that would be fine because they're very symmetric. But for Airjet Express, if they wanted to talk about their usual flight times, they would probably want to use the median as a better representation of their data because it is skewed. Okay, so Airjet Express would say our median air flight time is 4 hours, whereas cross-country would say our mean or average flight time is 5 hours. We should also be able to not just construct, but to read a dot plot. So be able to just be given a dot plot and make some claims about it. So a class was surveyed to determine the number of hours that were spent preparing for the final examination. The results are shown below. So the first question asks us how many students were surveyed. So to do this, I'm going to count the dots because every dot represents a result. So I have 1 for 0 hours, 2 for 1 hour, so that's 3 total, plus 3 for 2 hours, that's going to give us 6. And so we need to just keep counting these dots. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there were 20 students surveyed. Now to calculate the mean, I want to actually look at this data set written out, not as a dot plot. So this is where I have to be able to read the dot plot and translate it into my data set. So I'm going to say that there was 1 person who had 0 hours studying. There was 2 people who had 1 hour studying, 3 who had 2, 1 person who had 3. There was 4 who had 4. So again, I'm listing out my data set here. 2 people said 5 hours studying. 2 people said 6 hours studying. 3 people said 7 hours. 1 person said 8, and 1 person said 9. So now what I'm going to do is I'm going to add up all of those numbers. So I'm going to add up all of this data set. You're going to bear with me while I do this on my calculator because it's going to make my life a lot easier. And we get a sum of 87. Now we already calculated how many students, there were 20. So to find the mean, I'm going to do 87 divided by 20. And I get a mean of 4.35. Now we can also find the median. Now we can actually do the median from the data set that we just listed out in part B, right? So I could go through here and I could cancel out, right and left, and cancel those out, or left, right. Or I can actually find the median by going through on my dot plot. Now this is a little bit trickier. So if you're not super comfortable with these, I would definitely recommend going through and just canceling out on your list that you've already made from part B. So we're going to work our way into the middle. We're going to average out those 4s. So we have 4 plus 4 divided by 2, and that's going to give us 8 divided by 2, which is 4. Now you could also have done this from the dot plot, and so we would cancel out left and right. So I'm going to cancel out on the left, I'm going to cancel out that 0, and on the right I'm going to cancel out the 9. Now on the left I'm going to cancel out a 1, on the right I'm going to cancel out an 8. On the left, I'm going to cancel out a 1. On the right, I'm going to cancel out a 7. And so what I'm really doing here is I'm working my way into the middle. So again, if you're not super comfortable with reading these dot plots, I would not recommend doing it this way. But what we're going to end up with is those same two 4s in the middle, and we would average those two out, 4 plus 4 divided by 2, again giving us a median of 4. So we could do it from the dot plot. I would just be really careful when you're doing that. It is definitely safer to list out your data set, but I just wanted to show some of you guys who really get what's going on visually that you can find the median from the dot plot very easily. All right, so let's look at one more example. So the students in a class collected data on the number of minutes per day some kids spend brushing their teeth. Their data is shown in the dot plot below. So we have how long it takes them to brush their teeth in minutes, and then we have our dots listed out. So we see that there are 3 dots for half a minute, 2 dots for 1.5 minutes, 1 dot for 2.5 minutes, 2 dots for 3.5 minutes, and 1 dot for 4 minutes. And we want to know which statement correctly describes these data. So what I would recommend looking at here is first determining what you need to know. So all of these questions are going to be talking about the median being either 0.5 or 1.5, and then the mean compared to the median, whether it's greater than or less than. So in this problem, we have to calculate both the median and the mean. So in order to do that, I'm going to first list out my data set. So I have 0.5 happening 3 times, 1.5 happening twice, 2.5 happening once. I'm going to run out of space here. And then 3.5 happening twice, and 4 happening once. All right, so first I'm going to calculate the median because that's the easiest one to do from our data set. So I'm going to work my way into the middle, canceling out left and right. And we end up with a median of 1.5. So knowing that, choices A and B are out. So now I need to calculate the mean, that's our average. So I'm going to do this by adding up all of these values. So my total here, or the sum of our data, we would calculate by adding up 0.5 plus 0.5 plus 0.5 plus 1.5 plus 1.5 plus 2.5 plus 3.5 plus 3.5 plus 4 to get a total of 18. And so then our mean would be calculated by doing 18 divided by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data values to get a mean of 2. So now our median is 1.5, our mean is 2. So that means that the mean, the average, is greater than the median. So that's going to match